Hello, everyone. Welcome to our presentation about Cuttlefish. So Cuttlefish is our FTC software framework designed to improve both your programming experience and your code itself. So Cuttlefish has features that apply to both newer teams and more experienced teams and is designed to be customizable and expandable, meaning that wherever you are in your FTC journey, Cuttlefish probably has something to offer you. So Cuttlefish is broken up into two main modules. So the main Cuttlefish module, this module is actually not FTC specific and can actually be used outside of FTC. And this module contains general purpose features such as a localization system and a navigation system. And then Cuttlefish FTC Bridge, which contains features that are FTC specific. So as you might guess by the name, Cuttlefish FTC Bridge connects or bridges between Cuttlefish and the FTC SDK, allowing them to work together. And in the process, also adds some additional functionality. So some of this functionality includes built-in bulk pull support. So what that means is essentially it allows you to it automatically pulls data from all of your sensors at once instead of one sensor at a time, which is a lot faster and can improve your loop time by tens of milliseconds. And it also allows it also allows you to access hardware directly by port. So what this means is that normally when you want to access normally, when you want to access robot hardware, you have to use hardware map, and you essentially just have the config file on your phone. You put the name of the device into the config file and the information there. And then whenever you want to change stuff, you have to change it in the config file. And if you change the names or add new devices, you also have to do it in the code. So at least for Android Studio, we found that this isn't like particularly useful, since that like you still have to put the stuff into your code and it's all stored separately. So instead, what Cuttlefish allows you to do is to access devices directly by port number. So the reason that this is useful is because then, or an example of how this can be useful is this code right here. So essentially, this is an op mode that just initializes everything using the system. So, and as you can see down here, we've got all the motors being initialized directly by port. So now you can include this anywhere in your code. So here's an example of an op mode doing that, extending this initialized op mode here. So, and then you don't have to worry about initializing your code whenever you create a new op mode. It'll just do it for you. And then if you want to change any of the hardware on your robot or add new hardware, you don't have to touch the config file on the phone. Or if you want to check what port something's on for wiring, you don't have to touch the config file on the phone or on the hubs. You can just look at it in the code, which makes dealing with hardware and software together massively easier. And this op mode as well is actually also an example of just generally how powerful Cuttlefish can be, because this is a field-centric driver op mode, and you can see that it's a total of 9 lines long, and that's because of the initialization being able to be separated out, as well as some other Cuttlefish features that make programming your driver and other code more makes that easier. So a lot of these features here are actually features of the main Cuttlefish module. So now we're going to move into that. So the main Cuttlefish module is not FTC specific and has many general purpose features, like I mentioned earlier, like the navigation system and localization system. But a lot of it is based around something called the task queue, which is a scheduling system. So the task queue, as you might guess by the name, is essentially just a list of tasks. So a task is essentially just an object that has a loop function in it. And the queue essentially runs this loop function in this task every cycle of the main loop. So it'll essentially keep running this task continuously along with your main loop. And then when that task is done, it gets kicked out and it moves on to the next task in the queue. So this is useful for a couple reasons. So first is synchronization. So say you want to have code that is blocking, meaning that it prevents other code from running. So say, for example, you want to go to a location, deliver something to, you want to go to a location, deliver something, go to a different location, then intake, and you want these to run in order. This code has to prevent all of this code up here from executing, but you want this code to execute along with the rest of your code in the main loop, because this main loop code is dealing with all your sensors and PIDs and everything. So that, and ideally those should also be synchronized. So you aren't just constantly updating this go to location, like your motor powers, when you don't have any new data. So this allows you to synchronize those two together. So every time you get new data, it updates this go to location function until it's done with that, and then it moves on to the next function, or the next task, and the next task, and the next task. So that this problem is often solved by using a state machine in for your auto, but this allows you to get similar functionality without having to have the complexity of adding a state machine to your auto. You can also get more advanced execution like you would have with a state machine, because the queue, since it's just a bunch of objects, you can have queue items that add other stuff to the queue, or even tasks that contain tasks inside of them, or run multiple tasks at the same time. So you can get really complex like execution trees where you've got all sorts of parallel code running at the same time. So that can allow you to make really nicely choreographed autos where a whole bunch of stuff is happening at once without your code getting totally out of hand. Cuttlefish comes with a whole bunch of built-in queue tasks. So some examples of these are point tasks, which tell your robot to drive to a specific location, servo tasks, which to allow you to basically like set the position of a servo, and even custom tasks, which allow you to specify your own function. And I see a question in the chat of how the main loop is stopped once all the tasks are done. The main loop is actually not stopped once all the tasks are done. Essentially, once all the tasks are done, essentially the queue will just be empty, and then there won't be there won't be anything else to do. So it'll just sit there idle, and then whatever you're using to stop the code, either whether that be the stop button or the auto ending, that is what actually stops the code. But there isn't anything else running once there's nothing left in the queue for it to run. It'll just stay idle. And so, where was it? Oh yeah, so built-in tasks, bunch of built-in tasks. You can also add your own tasks. So that means that even if you want to have your own custom code, like say you have your own navigation system, or that is like a custom navigation system, and you wanna have that, but you also want to use Cuttlefish, you can totally do that and just add that to this queue system. And that means that Cuttlefish doesn't inhibit you or impede you from using your own custom code. So I see someone in the chat asking if the Cuttlefish is already in the FTC SDK, and that's actually perfect timing because I'm going into installation next. So it is not already in the FTC SDK, but it's really, really easy to install, because all you have to do is go into this file, build.dependencies.gradle, and add 2 lines. That's it. Well, you just do that and then hit the Gradle sync now button, and Cuttlefish is added to your project. And since you're probably not going to remember these like random lines of code up on the screen, we've got a documentation page which can be found at this link or through this QR code right here, and that can show you how to install Cuttlefish, as well as how to use it, and what all its features are, etc. So that's up on the screen now if you want to go check that out. And yeah, that's it for my presentation. Any questions?
All right, thank you so much, Logan, for the presentation. Do we have any questions in person? All right, if not, I think we have a few online ones. One from FTC 25783. How exactly is the main loop stopped once all the tasks are done?
Oh yeah, I think I already answered this during my presentation, but essentially the main loop keeps running, but it doesn't the queue is like once the queue is empty, it just doesn't have anything else to execute. So it'll still like keep watching your sensors and making sure that everything's okay, but it's not going to be actively doing anything because the queue is not run. There's no code in the queue for it to be running.
Okay, thank you so much. All right, any other questions for in person? If not, we'll move on to our next presenter. Thank you so much. Let's give it up for Roboctopi. Thank you.